Hi, I'm Farhana and welcome back to the fourth lesson on trigonometry rules. In this lesson, we'll consolidate what we learned in the last three lessons on all three rules. Let's begin. So, I'm sure you've always wondered how you'd know which rule to use in any given triangle. That's the question we're going to answer today. Let's quickly look at our concept map though. So, remember again, we're dealing with solving non-right angle triangles, and so far we've done the sine rule, the cosine rule and the area rule. Let's quickly recap what all three rules are. I hope you remember all three rules. They were pretty simple to memorize. We did do some tricks to try and make it easier to memorize them. So let's see how much you can remember. Okay, so first we're going to do sine rule, and remember the sine rule for any triangle ABC. There's two versions. The version with the angle on top, sine A over A equals to sine B over B, which equals to sine C over C. And this version is the version we use when we're trying to find angles. The second one we have is the version with the sides on top. It's just a reciprocal of the previous one. So A over sine A equals to B over sine B, which equals to C over sine C. Now, can you remember when do we use the sine rule? What's the criteria for that? Let's check. Okay, we need to have one full pair and one half pair. So we need one pair of angles and sides. We need to be given one pair, and we need one half pair. So either we can be given that and then we can find the angle, or the other way around. Okay, and remember in sine rule there's the ambiguous case. Can you remember when the ambiguous case is applied? Remember sine rule you need one full pair of angles and sides and one half pair. But the ambiguous case is a specific case of the sine rule. This occurs when we have two sides and an angle given, but specifically remember the full pair that we're given contains the smaller of the two sides. So the full pair that we're given contains the smaller of the two sides. 6 is smaller than 10, and so we will have the ambiguous case. Remember, when we have the ambiguous case, it means we can draw two different triangles with the same information. Okay, and the next rule that we did is the area rule. The area rule was pretty simple. We used the area rule to find the area of a non-right angle triangle. Can you remember? This was pretty easy to remember. Half, if you had an AB and then you put a C there. So it was half AB sine C. Second version, half BC sine A. And I'm sure you can recall the third version. It's half AC sine B. Now, can you remember what you need to use the area rule, what you need to be given? That's right, you need side, an included angle, and a side. So for area rule, you need to be given side, angle side, and it needs to be an included angle. Okay, and the last rule we did was cosine rule. So you could use cosine rule when you had two sides and an included angle, and then you'd use the standard versions of the cosine rule. And let's remind ourselves for triangle ABC, it was a squared equals b squared plus c squared minus 2bc cos A. B squared equals a squared plus c squared minus 2ac cos B. And the third version, c squared equals a squared plus b squared minus 2ab cos C. So there was another situation when we used the cos rule. Can you remember what that was? Correct, when we were given three sides. So when we have three sides, then we can use one of these versions of the cos rule. So if we want to find cos A, then we'd use, if we want to find angle A, then we'd use this version of the cos rule. So basically we just use the original versions and we just manipulate it a little bit until we have cos A, the subject of the formula. And then remember, we'll use shift cos to find the actual angle on our calculator. And similarly, if you were looking for angle B, then this is the formula that you're going to be using. And if you're looking for angle C, then this is the formula you're using. You don't need to know these formulas off by heart. You can use the original formulas and just manipulate them to get to this version. Okay, now let's see if you can understand how to put all three rules together and decide which is the most appropriate to use in any given situation. Let's summarize this quickly. So, which rule to use? Pretty simple. Okay, first we've got to ask ourselves, is the triangle right angled? If it is, then we have to ask, does the question involve angles? So if it involves angles, simple. Now we're just going to use grade 10 work. And what was the grade 10 work? It was the introduction to trigonometry where we did the trig ratios. So we've got to use the SOHCAHTOA, sine equals to opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, what happens if the question doesn't involve angles? Then you've got to use the theorem of Pythagoras. Okay, then we're using the theorem of Pythagoras to find the sides. What happens if the triangle is now not right angled? What happens in that case? Okay, then we've got to see if we have one full pair, that means we've got an angle and its matching side. If we have the angle and its matching side, then what rule is that? Of course, it has to be sine rule. So if we don't have one full pair, what's the other option to use? We have to use cos rule. So let's look at this again. If the triangle is right angled, if it involved angles, then you're going to use our grade 10 work. If it involves only sides, then you're going to use theorem of Pythagoras. If the triangle is right angle, not right angled, and then if you have one full pair, then you can use the sine rule. And if you don't have a full pair, then you're going to use the cosine rule. Okay, it seems a little bit complicated maybe perhaps right now, but it'll be very easy soon as we look at some actual triangles and decide which rule to use. So let's go and do that. Okay, in this first triangle, let's first answer, is it right angled? No, there is no right angle in this, so there is no right angle in here. Okay, do we have one full pair of angles inside? Yes, we have one full pair of angles inside. So which rule will we use here? Easy, we're going to be using the sine rule. And if we're using the sine rule here, what will we be finding? We'll use this as our half pair and we'll be finding this angle. Okay, let's go to this next triangle here. Start asking our questions again. Is it right angled? Yes, it is a right angled triangle. So because it's a right angled triangle, we're going to ask our question, does it deal with angles? Yes, it's dealing with angles. So because we're dealing with angles, it means we've got to use our trig ratios. So we've got to use one of our trig ratios here. And if you look at this specifically, depending on what you wanted to find, because you wanted to find the adjacent angle and you're given the hypotenuse, you're going to be using cos of 25 is equal to A over H to begin solving that triangle. Okay, we've got a few more to practice on. Let's look at this. This one here, is it a right angled? No, it's not a right angled triangle. Does it have any full pair of side and matching angle? So we've got no full pair as well. So what does it mean we have to use? We've got to use cos rule. And cos rule, why? Because we have side, side and side. And we use cos rule, we can find any of the angles. Look at this triangle again. Again, it's a right angle triangle. And yes, it involves angles. So again, we're going to use one of our trig ratios. Specifically, which trig ratio will we be using? We'll be using the one that says opposite over hypotenuse. So we'll be using our sine is equal to opposite over hypotenuse. Okay, the next one again, here we've got what? Do we have a not right angle, is it a right angle triangle? No, it's not right angle triangle. Do we have a full pair? No, we don't have any full pair, if you look at it correct. All we have is a side, an angle, and a side. So we have that V pattern. So we're definitely going to be using cos rule here. Okay, I hope this is getting a little bit easier. Let's try. I think we've got two more left to do. This one here again, it's a right angle triangle. And if you notice carefully, there is no angles given. So because there is no angles given and we want to find sides, we're going to use Pythagoras to solve this triangle. Okay. This one here, we have one full pair of sides, so it's going to be sine rule. Okay, I hope this is getting a bit easier for you. This one here again, it's a right angle triangle and it's involving angles. So again, you're going to use your trig ratios from grade 10. Okay, so I hope you have some idea of how to decide which rule to apply when looking at a specific triangle. After the break, we'll continue with looking at some specific examples in solving the triangles. Hi, welcome back. So remember before the break, we were discussing when to use which rule. Let's look at that in the context of an actual problem. Okay, here we say given that two cars are parked on a street at A and C. Joe standing at point B. What is the distance? They want us to determine the distance from B to C. So they want us to determine that distance. So if we want to label this triangle, this is little a, this is little b, and this is little c. So if we go through all the steps to decide which rule to use, let's start at the beginning. Is it right angled? It's not right angled triangle. Do we have one full pair? Do we have a full pair? And if you look carefully, there is no full pair. We don't have, we've got this side, but we don't have the angle across it. We've got these angles, but we don't have the sides across it. This problem is slightly interesting because we don't have side angle side either. But what we can do is, because we're given two sides, two angles, 50 and 50, we could easily find this angle B, and of course angle B will just be 180 minus 50 minus 50, which is 80 degrees, which we'll work out in a second. But once we find B, we will then have one full pair. Then to find any of the other sides will be pretty easy by simply applying the sine rule. Okay, so when we're calculating B, we've got to calculate B quickly. Let me just erase this. Okay, so we're going to calculate B like we said earlier, and B, remember, because it's angles in the triangle and we have the other angles equal to 50, we just subtract it from 180, and so B is just going to be, 80 degrees. Okay, now that we have B, we're going to use the sine rule to find BC. And again, remember, we're finding BC, or we're finding little a. So because we want to find a, we're going to use this version of the sine rule that starts with a as its numerator. So the version we're going to be using is a version that starts off with a or BC as a numerator. So BC, so that over sine of the angle across it. So we're going to have sine of 50 degrees. Okay. And on this side, we have to put our full pair. So what's our full pair that we're given? Our side is 10 meters. And our angle is now this angle B that we've calculated here, which is 80 degrees. Okay, and rearranging this, remember we're just going to multiply throughout by sine of 50, so we isolate the BC on the left hand side, and so we're going to end up with BC is equal to 10 times sine of 50 divided by sine of 80. We've just multiplied throughout by sine of 50. Okay, put this into our calculator quickly. So it's going to be 10 times sine 50 divided by sine of 80 degrees. So our answer is 7,7786. Remember again, we are rounding off to 2 decimal places. So the 0.77 will become 0.78. So the length of BC will be 7,78 meters. Okay, let's try another question, the second part of the question. They ask, what is the shortest distance from Joe to the street? Remember again, Joe was standing here. And when we discuss the term shortest distance, we're talking about the perpendicular distance from this point to this line. So basically, we can construct this line BD that's perpendicular to AC. Now remember, this is an isosceles triangle because both these angles are equal to 50. So it means that this purple line BD that we've just drawn in will divide this 10 into half. So this half will be 5 meters exactly, and this half from A to D will be 5 meters as well. So AD is 5 meters and DC 5 meters. Both of these are 5 meters. Now let's go back to the question again. What is the shortest distance from Joe to the street? So what they want us to find is they want us to find the length of BD. Now, BD is in which triangle? BD is part of this triangle here, isn't it? It's part of actually the other triangle as well, but we're going to work with this one here. It's part of triangle BDC. So it's part of triangle BDC, and triangle BDC is what kind of a triangle? It's a right angle triangle, and remember our rules say that if it's a right angle triangle and you're dealing with angles, it means you've got to go back to your grade 10 trigonometry. So which ratio from grade 10 trigonometry will we use? Remember, we've got this side which is adjacent, and we want to find the opposite side. So which ratio uses opposite and adjacent? The ratio that uses opposite and adjacent is our tan function. So if we say tan of 50 will equal to BD all over, so opposite over adjacent, and our adjacent one was 5 meters. So we just got to rearrange this. So in other words, BD will equal to 5 times tan of 50, plug that into our calculator, and oops, sorry about that. Plug them into our calculator, we're going to get an answer of 5.9587, and remember, because we're rounding off to 2 decimal places, our answer will simply be 5.96 meters. Remember, you've got to put in your units there, so when you're giving your answer, your final answer, you've got to give in your units. So back to the question again. In this question, we had 2 different kinds of triangles. So because we actually had 3 triangles in this diagram here. We had a non-right angle triangle and we had 2 right angle triangles. So using our rules of when to apply which rule will help us to try and break down the problem and decide which route to take to find an angle or side as needed. Let's try one more example. In the diagram, determine the length of Pn. So we've got to find the length of Pn. They want us to find this side here. Now let's quickly just look at this diagram and try and break it down and see what we have. So obviously we've got 2 triangles. We've got this triangle that's right angled, and we've got this triangle that's non-right angled triangle. So generally, to solve a right angle triangle, you need to have two bits of information. So if you look, we've got one angle and we've got one side, which means for this triangle, for triangle LMN, because it's a right angle triangle, we can use our SOHCAHTOA rules. Okay, so we can use our sine, cos or tan rules for that one. So, but for this triangle here, this second triangle here, LPN, we're not given any sides, we're only given these two angles. So we need to find at least one side. So because the only one we can solve at the moment using the given information is our right angle triangle, we're going to start off first by finding LN. Once we found LN, we will then have one full pair to work with. Then this triangle becomes solvable. Okay, so let's go see how we're going to answer that question. Okay, so sine of 55 is equal to 34 over ln, opposite over hypotenuse. So rearranging this a little bit, we're going to end up with ln is equal to 34 over sine of 55. Now because we're going to use the answer to find Pn, I'm going to leave my answer like that, and I'm going to substitute ln by using this fraction for ln. So that's what we just found out now. And now we're going to go to this triangle here. So in this triangle here, because we want to find Pn, we're going to say Pn and we're going to say over sine of 35. So Pn over sine of 35 will equal to, now remember we found ln, so we've got to put ln in here, right? So it's going to be ln times the sine of the angle across from it. And across from this, we've got 74 degrees. Okay, so in the second step, all I've done here is just rearrange it and multiply by sine of 35 just so I can isolate Pn on this side. Okay, now we're going to take this ln and we're going to substitute it in here for ln. So we're going to take it exactly as it is because we want to be accurate. We don't want to lose any decimal places. So that's why we didn't use a calculator at this point. We're going to use a calculator only after this. So I'm going to plug in that piece for ln, which was 34 over sine of 55 degrees. Okay, and this sine of 35 was there, and this, I'm just repeating the denominator. Now I'm going to put this whole piece into my calculator, and you plug it in. If you want, you can do it like this, or you can simplify it in one more step like that, where you just take the sine of 55 at the bottom and you can decide how you want to get through the algebra here. It's fine. Either way you do it, even if you put in the calculator exactly as it is, you get an answer of Pn is equal to 24,77 units. And so finally, you'll end up with an answer for Pn. Hi, welcome back. So we're discussing which trig rule to use given a specific problem. Let's recap. So which rule do you use when? Can you remember? We'll check first if the triangle is right angled. If the triangle is right angled, we ask ourselves the question, does it involve angles? If it does involve angles, then we go back to using just our grade 10 work. Okay, so we're using all our trig ratios, SOHCAHTOA, so sine and cos and tan. If there is no angles involved, then it's just theorem of Pythagoras. Okay, and the grade 11 work involves non-right angle triangles. So if the triangle is non-right angle, you need to check if you have one full pair of angle and its matching side. If you have a pair, a full pair, then you need to ask one more question. If you have the one full pair, then you know you can use the sine rule. If you don't have one full pair, then you've got to be using the cos rule. And remember, for cos rule, you need to be having either side angle side, and remember here it must be the included angle, or you must be having side side side. Okay, let's look at our first example, and here they tell us BCD is a straight line as shown. Determine the distance from A to B. So the first question wants us to find the length of AB. Okay, this diagram is slightly complicated and we've got to break it down. So if you notice, we've got three different triangles. We've got this little triangle here, ABC. We've got another triangle here, ACD. And then we've got the big triangle, ABD. Now, because they want us to find AB, AB is contained in this little triangle here. It's also contained in the big triangle. Now, which bit of information will be used to find AB? Okay, if you look at it carefully, in the big triangle we've got more information, because in the big triangle, if we disregard line AC, in the big triangle we have an angle, and we have another angle, and we have this side. So let's see if we can use the big triangle to find the distance from A to B. Okay, so here's our triangle drawn without line AC, just to make it a little less complicated. Remember again, we want to find AB, the distance from A to B. Okay, so I need to have at least one matching pair. So again, because I'm given these two angles, I can find this third angle pretty easily using the three angles of a triangle. So, okay, so angle A will simply equal to 180 degrees minus 38 minus 50 degrees, and that's going to equal to 92 degrees. Okay, once we found that, we can say use the sine rule now, because now we know that this angle here, is 92 degrees. Okay, now we're going to use the sine rule. There's our full pair and that's our half pair. So let's begin by writing what we need. So we want to find AB. So we've got to write sine of the angle across from AB, which is 50, and then we've got to use our full pair. So our length of our full pair that's given is 114, and the angle that we're now going to use is the angle we found, because across from 114 is 92, so we're going to put in 92 degrees in there. Okay, now we know what to do. The algebra is pretty simple. We've got to just multiply, we've got to just get rid of this we've got to get rid of the sine of 50, multiply both sides by it, and we ended up with that. We put that into our calculator, and I think you guys are quite comfortable with the calculator at this point. This is a simple calculation. And remember, when you get your answer on your calculator, you need to make sure that you're rounding off correctly. In this case, the rounded off answer will be 87.38 units. Okay, so I hope this is getting slightly easier for people. Let's try one more example. Okay, so this question continues. It says, okay, now we've got to find the distance from A to C. Now they're asking us for a different distance. They want us to calculate this distance here, A to C. So we're obviously going to use the smaller triangles, but they've given us one additional piece of information. They told us that this side is 65. So we know we're going to be working with just the small triangle here now. Okay, let's look at what they need to, what they need from us again. They want us to calculate this side, and what do we have? We've got a side, we've got no full pair, but we've got a side, included angle, and a side. So we have side, angle, side, and it's the included angle, so therefore we're going to be using cos rule. Okay, and how will we use cos rule for this one here? Easy. We want to find AC squared Okay, so we're going to say AC squared is equal to, and we're going to start off by let me just grab my highlighter quickly. We're going to use, it's going to be that side squared, and that's where we get that from. Okay, that squared plus 65 squared, which is our other side. So 87,38 squared plus 65, and then again we've got to put in 87,38, 2 times 87,38 times 65 times the cos of the angle in between. And the angle in between, remember, was 38. So therefore we put cos of 38. Okay, so we're going to put this into our expression into our calculator, and the calculator will give us a result for AC squared being 2908,935. Now again, remember, this is the value for AC squared. We want to find AC, so we need to take the square root of this. So you'll go shift and you'll find the square root of your answer on your calculator, and so sorry, this should just be AC. So AC is then 53,93 units. Okay, let's just do one more example. So here they've asked us to calculate the area of ABD. So how are we going to calculate the area of ABD? What do we need to find the area? For area we need side, angle, side. So how are we going to find the area? So it's easy. We're going to say we're going to use side, angle, and side. So area will equal to half 87,38. Our other side is 65, and it's going to be sine of 38 degrees. Okay, and we put that in the calculator. The calculator will give you the answer of 3066,40. Remember, we rounded off to 2 decimal places. So it's 3066,40 units squared. Okay, our next example, we have A, B, C, D, and they've given us that we've got 12, 8, and 10 as the 3 sides for the lengths of the 3 sides of that triangle. They want us to calculate the size of B2. So how are we going to calculate the size of B2? In order to calculate the size of B2, remember we're going to use sine rule. Because we've got side, side, side in that triangle, we're going to have to calculate, we're going to have to use the sine rule. And because we want to find B2, we're going to begin with the side across B2, which is CD squared. So CD squared will equal to, and now we're going to use the other 2 sides of this triangle, which is BD squared plus BC squared, BC squared minus 2 BD times BC and cos of the angle across it. So we want to find cos of B. Remember, that's the one that we want to find. Okay, so now we're just going to rearrange that. So if we rearrange that, we'll end up with BD squared plus BC squared, and we're going to take the CD onto this side, so it will become negative CD squared. And so we'll end up with cos of B2 will equal to BD squared plus BC squared minus CD divided by 2BD times CB. Okay, we're going to substitute in now the values that we need to. So in other words, okay, substituting, we're going to get BD is equal to, oh sorry, let me just grab my pen. BD is equal to 10, CB is equal to 12, and CD is equal to 8 times 2 BD and CB. Okay, and remember, because we're finding an angle, we now need to use the shift function in our calculator. So we're going to put shift and we're going to put in this whole expression into our calculator. I think you're comfortable with that, so let me just give you the answer. Okay, so you're going to end up with B2 is equal to 41,41 degrees. So this angle here is going to be 41,41 degrees. Okay, now they ask us to calculate the area of ABD. So ABD is this right angle triangle here. So in order to calculate this right angle triangle here, we've already calculated in the previous slide, let's just remind ourselves quickly, that B2 was 41,41. So this angle here is 41,41. But remember, this angle is alternate to this angle. So B2 is equal to D1 because they make a Z pattern. Okay. So because they're equal, I now have an angle on one side in this right angle triangle, which means I can solve it and I can find the area. Now we want to find the area, so I want to say area will equal to half AD, half base times height. That's the formula that we're going to use, the regular area formula. So the regular area formula, okay, so we said now D1 will equal to B2, and remember they're both going to equal to 41,41 degrees. Okay, so both these angles are going to equal to 41,41 degrees. Okay, we're now going to use the cos ratio in this triangle, the right angle triangle, to find AD. So let me just grab my pen again. So this is the adjacent and this is the opposite. So we're going to use cos of D1 is equal to AD over 10. Okay, and we're going to just rearrange this. So we make AD the subject of the formula. AD equals to 10 times cos of D1, which is 41,4 degrees. And similarly, we're going to find the length of AB using sine. So if we're going to find the length of AB using sine, AB is the opposite angle. So we're going to say sine of D1 is equal to AB over 10. So rearranging this, AB is equal to 10 times sine of 41,41. So in this triangle, we can use our half base times height formula. We can use our AD, half AD times AB to find our area. Because it's a non-right angle triangle, we use our simple formula. So triangle AB is equal to half AD times AB, and we're going to substitute these exact values as we found them. So we're going to substitute that for AD, and we're going to substitute this for AB. Okay, and all that's left to do is put it into the calculator, and the calculator will give us this answer here of 24,80. And remember, I've already rounded this off to 2 decimal places. Okay, what's left in this question is to calculate the area of BCD. Now this is different from the previous one because BCD, this triangle, is not a right angle triangle. So we've got to look for what? Side, angle, side. So the side, angle, side we're going to use, we've got that side, okay, and remember we have this angle here, and this angle was 41,41, and we can use that. So there's our V pattern, our side, our angle and our sides like that. So we can use that to find our area. So area, if you write out the formula, it's going to be area is equal to half BC times BD times the sine of the included angle. Okay, so BC, our value was 12 and our BD value was 10, and put that into the calculator, and there's our answer for the area. So the area is 39,69 meters squared. Okay, that was a reasonably complicated example. I hope you managed to keep up with us. Join us after the break where we will continue with another example. Hi, welcome back. So before the break, we were looking at examples to see which trig rule we need to apply to solve a particular problem. Let's continue with that. Okay, in this diagram, we asked to find the length of BD correct to just one decimal place. So here we're working slightly differently. We're working with 1 decimal place, and they want us to find the length of BD. So we're going to examine our triangles and we see what information we have. If you look at this triangle here, as it stands, we've only got 1 bit of information. So because we only have 1 bit of information, we cannot solve this triangle at the moment. Let's look at this other triangle we have here. We've got 3 bits of information, so it sounds a bit better. And we notice that we have 1 full pair already. So if we have 1 full pair, we know in this triangle we can definitely use the sine rule. And if we did use the sine rule, we could use this full pair and this half pair. And so we could find what they are asking us to find, which is the length of BD using the sine rule. So how do we write that out? So remember, it's going to be BD over sine of the angle across it. Let's start writing that out quickly. Okay, so BD, and the angle across from BD is this angle here. So we're going to say sine of 30. And our full pair we're given is the 3 meters. And the angle across the 3 meters is 120 degrees. Right, so we're going to just rearrange this equation to get rid of the sine 30 from our left hand side. And so we end up with BD is equal to 3 times sine of 30 over sine of 120. Okay, put that into your calculator. So it's going to be 3 times sine of 30 divided by sine of 120, and our answer is 1,7320. Remember, we've asked to find BD correct to 1 decimal place. So 1 decimal place means 1,73 becomes 1,7. So our answer for BD is 1,7. Okay, let's go to the next question. The next question now, they want us to find the length of BC. So because they want us to find the length of BC, so we've already found out that BD is, sorry, let me just grab my pen. I seem to have lost it. Okay, so BD is 1,7 meters. Okay, but now they want us to find the length of BC, so we've got to work with this triangle. Okay, now again in this triangle we've only got 2 bits of information. We're obviously missing something else. So we've got to go back to our diagram and look to see what else are we missing. Can we find a different angle or a different side? And remember, when we were working out earlier, we looked at this triangle here. But this triangle, because we had 2 angles, we had 120 and 30, we could find this angle here, B2. And because we have parallel lines, B2 lies alternate to D1. So if we find the value for B2, we can find D1. And once we found D1, we have a lovely V pattern here. We've got a side, an angle, and a side, which will allow us to use cos rule in this triangle. So let's go and write that down. So because we know that BD is 1,7, we're going to first find B2. And B2 will be 180 degrees minus 120 degrees minus 30 degrees, which is going to give us with 30 degrees. So that's going to be the same, because B2 is 30 degrees, it means that D1 will also be 30 degrees. Okay, so B2 is 30 and they alternate, so therefore D1 also has to be 30 degrees. Okay, now we're going to try and write out the cos rule for this triangle here. So for this triangle here, because we're trying to find BC squared, remember we're going to use that side squared, 1,7 squared, plus the other side that we have, so it's going to be 1,5 squared, minus 2, and remember we've got to use this one and then that one in our bracket. So we've got 1.7, we've got to put a 1.5 in here, and the cos, the angle across BC squared, and the angle across, the angle across BC is D1, which we already realized is 30 degrees, so we're going to put in a 30 degree in here. Okay, now remember this is what BC squared is equal to. We've got to put that into our calculator. That's still not our answer because we want the value for BC. Although our calculator will give us this answer. This is obviously not the correct answer yet. We're going to take the square root of that. And so we take the square root of that, and then we end up with BC is equal to 0,9 meters. So we've answered that question because the question said find the length of BC, and we've used the cos rule to find the length of that one. Okay, so we're almost at the end of our session now. Let's quickly recap how we can decide which rule to use. Let's go. So remember, when we're deciding which rule, we've got to decide if it's right angle. If it is right angle and involves angles, then we've got to use our trig ratios. If it does not involve any angles, then we've got to use the theorem of Pythagoras. If indeed it is not right angled, then, oh, did I say something wrong? I felt like I said something wrong there. Sorry, can I just do that again? I felt like I said something wrong. Sorry, my ear was busy buzzing. My nose and my ear just got blocked. Sorry. So can I start here with which rule?
Yeah. Yeah.
Can I start?
3, 2, 1.
Okay, so we first check if the triangle is right angled. If it is, then we ask ourselves the question, does it involve angles? And if it does, then we use our trig ratios. If it doesn't involve angles, we've got to use the theorem of Pythagoras. Then we have the case where it's not a right angled triangle. We come to, we've got to then ask ourselves, do we have one full pair? That means an angle and its matching side. And if it is, it means we've now have the criteria for using sine rule. So in that case, we'll use the sine rule. And remember, sine rule is used when I have angle, angle, side, or sine, side, angle. And the last but we need to know that if we don't have one full pair, then we know we can use the cos rule. And remember, for the cos rule, we need to have side, side, an included angle, or we're going to have side, side, side. Okay, so that brings us to the end of this lesson where we were deciding which trig rule to use when. Okay, I hope you join me next time where we'll be looking at some of the proofs of these rules, and we will be extending them to slightly more challenging questions. Till then, bye.